Okay, so in the last video, we looked at just kind of the theory, the rule as far as order of operations and the distributive property go. In this video, we're going to consider a couple different examples associated with order of operations. All right, so let's go ahead and get started. So again, we're looking at this video just simply at examples of order of operations. The next video will have some examples of the distributive property. So here we go, example number one. Let's revisit the case in point that we considered in the last video. We talked about if you do this problem by doing the addition first and then the multiply, you get an answer of 50. If you do the multiply first and then the addition, you get an answer of 22. So which is the right way to do it? Well, our order of operation 4 steps are grouping symbols, exponents, multiply and divide, add and subtract. Okay, gosh, excuse my dear Aunt Sally, right? Multiply and divide left to right, and subtract left to right. So those are our order of operations. So I've got an add and I've got a multiply. This comes before this, right? This comes first, second, third, fourth. This one comes last. This one comes third. I don't have any grouping symbols. I don't have any exponents. I'm going to start here with this multiply. 3 times 5 gives me 15. Notice everything else I leave the same. I don't change anything except for the step that I'm on. And then last, I can do the addition. 7 plus 15 is 22. And so 22 is considered the right answer to this problem. Okay, let's take a look at another example. Suppose I have 3 times 3 plus 3 squared minus 3. Okay, so what happens here? Well, we have these same order of operations. Grouping symbols come first, exponents second, multiply and divide from left to right third, and add and subtract from left to right is fourth. So here again, I don't have any grouping symbols, but I do have an exponent. So I'm going to start right here. Even though it's in the middle of the problem, I'm going to start right here with this exponent. 3 squared means 3 times 3. That equals 9. So if I simplify this piece, I get a 9. Everything else stays the same. So after the 9 is still a minus 3. That hasn't changed. Before the 9 is still a plus sign, and then a 3, and a multiply sign, and another 3. So the only thing that changed was that exponent piece. Right? Now on this step, I'm going to move from the second step to the third step and take care of my multiplies and divides. Well, there's only one of them. So I have 3 times 3, which is 9. So this piece becomes a 9. Everything else stays the same. And now all I have left are adds and subtracts, and I'm going to do them in order from left to right. So first, I start here and I do the addition. 9 plus 9 gives me 18. And then I come here and I do the subtraction. 18 minus 3 gives me 15. And so that would be a problem that has exponents in it. Okay, let's take a look at another one that has parentheses. So if I have 3 plus 5, and then I have a minus 4 times 6 plus negative 2 squared. Okay, so now we've got a lot of parentheses flying around here. So this is where it's important for you to remember that it's not really parentheses, it's grouping symbols. And specifically, it's what goes inside the grouping symbols. So here I have 2 sets of parentheses. Which one am I going to do on my first step? Well, I'm going to do this one because this one has something on the inside that needs to be done. On this one, there's nothing inside that needs to be done. There's just a negative 2 sitting there. These parentheses actually are not acting as a grouping symbol. What they're doing is telling me that the entire number negative 2 is getting squared. So it's acting in a slightly different way. There's nothing to do on the grouping symbol step. So here's my grouping symbol step. 3 plus 5 gives me 8. And that's the only thing that changes on my grouping symbol step. Now I can move to my exponent step. This means I have a negative 2 squared, or in other words, a negative 2 times negative 2. So that equals a positive 4. And the next thing comes multiplication. Well, there's only one multiply. It's right here. I've got a 4 and a 6. So that gives me 24 when I multiply those together. And now I'm going to add and subtract from left to right. Okay, so from left, I get 8 minus 24. Well, 8 minus 24 is going to be a negative, right? Because 8 is too small to take 24 away from it. So I'm going to end up negative 16 plus 4. And then negative 16 plus 4 leaves me with a negative 12. Okay, so there's a few examples. This was example number 3. Sorry about that. There's a few examples there of using the order of operations to simplify a numerical expression. Thanks for watching.